All right, let's look at example 3, I'm calling it here. So it says to factor 81x squared minus 25. And we're going to treat that this is a pattern of the difference of two squares. But you can still do it the exact same way we've been doing all of our factoring problems. We just don't have a b value here. So it is okay to just think of this as 81x squared plus, there is no x's, minus 25. And we could just, insert that 0x in there and then factor this using the snowflake method. So I'm going to have my two parentheses here. I'm going to go with snowflake and do the same thing. The only problem here is that 81 and 25 are large. That is a large c value, but you can still do it, right? So the a value is 81, so that goes here. The b value is 0, and then the a times c value is negative 2025. And so, we need to figure out what multiplies up to negative 2025, but adds up to 0. Now, since it adds up to 0, these numbers here would have to be the same thing, right? So the two numbers have to be the exact same thing. Therefore, you can take 2025 and just take a square root of that, right? And you'll find your answer. So this would have to be 45 and negative 45. So 45 times negative 45 is negative 2025. And then if you add them, you get 0. So that's correct. And then we could do the same thing and then reduce these columns. And if you look at 81 over 45, they both have a common factor of 9 there. So if you treated these as fractions, 81 over 45, if you reduce that fraction, you get 9 over 5, right? So there's my reduced, and this should be negative, right? So it'd be 9 over negative 5, and then if I reduced this column over here, I would just have 9 over 5. So there's my reduced column there. So therefore my answer is 9x plus 5 and 9x minus 5. Now, some people would say that there's an easier way to do that problem, and there is a pattern that shows up, and that is, this is the difference of two squares. And whenever you have the difference of squares here, meaning if I have some perfect square minus another perfect square, this always will factor, or can be factored as or a minus b and a plus b. This always works. And so if we treated, another way to do this problem, if we treated this as the difference of two squares, you can see that the first term is 81x squared. Well, that is, you can take a square root of that. It's a perfect square, meaning 81x squared could be written as 9x squared, because 9x times 9x is exactly 81x squared. And then you could take minus, and 25 is a perfect square as well, and it is 5 squared. So because you can write these two terms that you're subtracting as perfect squares, you can see the inside here is 9x, and the inside over here is 5. So if you look at this pattern that we have up here, my a value is 9x, and my b value is 5. So therefore, we could jump right to the answer and say, hey, my factoring is going to be 9x minus 5 and 9x plus 5. And then I could be done, right? So there's a pattern there. I could say 9x minus 5 and 9x plus 5. And then you could use a difference of squares. What I would suggest doing is I would continue going with the snowflake method until you feel very comfortable with it, and let these patterns kind of come to you. Once you start seeing that pattern more and you start to memorize it and say, oh yeah, this is the difference of two squares, I can take a shortcut there, then go ahead and do it. But if you're still a little iffy and need more practice on, like just the normal way to factor, then just keep doing it the normal way, because that's always gonna work. But as you get more and more comfortable and more experienced with factoring, you're gonna start to use these special shortcuts. But you don't have to force the shortcuts as you're learning. You can kind of let them come to you. You can use the standard way to do it, and then as you get better and better and notice them, then you start to pick up those extra tools. All right, so here's another one. And again, the numbers are large. This is a perfect square trinomial. So there's a pattern here, but go ahead and pause it and see if you can do this one first. All right, so we're going to break this into two parentheses. And if I just went with my traditional snowflake, the numbers are going to be big. We'll first do it like that though. So 40, this would be 49, 49, this is 112, and then 49 times 64, which is 3136. 3136. And so we'd have to multiply up to 3136 and add up to 112. Now 3136 is a perfect square. So if you were to take the square root of that, you get 56. And 56 plus 56 is 112. And then we would reduce that. So we would have 49 over 56. And if you reduce that fraction, you get 7/8. So this goes right to 7/8, and this column reduced to 7/8, and then you could get your answer like that, right? So this would be 7z plus 8, and 7z plus 8 again. So you could actually write your answer, because we have two factors that are exactly the same. You could write your answer as 7z plus 8 and squared. So this right here is another one of those patterns that might not immediately jump out at you, but this is a perfect square right here. This is a perfect square trinomial right here. And if we have that perfect square trinomial, there is a pattern to it, but again, I typically just go ahead and factor it anyway. Most of the time I don't even recognize it as a pattern unless it's really obvious. But the perfect square trinomial says if you have, like, if the first term is a perfect square, so let's say we have an a squared, and the last term is a perfect square as well, so let's say this is a b squared, a squared plus b squared, and then you have this middle term which happens to be 2 times a times b, which is the case here, right? Then this could be factored to a plus b squared. So that's the pattern. That's a perfect square trinomial pattern. And we saw this, I think, in chapter 5 at some point when we were multiplying things out, that if we were going from here to here, you could also follow that pattern. Or you could just write that thing out twice and be done with it and just multiply it the normal way. But if you did it with the pattern, but you don't have to, but you could recognize this as the a value in our problem here is 7z, and the b value in our problem is 8. And it is true that the 2 times a times b, so 7 times 8 is 56, and double that is 112. So that does match up. This is a perfect square trinomial. So therefore, since this works, we can go ahead and directly factor this as 7z plus 8 squared, and we could be done with it. Again, it's totally okay if you start factoring it, and maybe you notice that as you're going through it, and maybe that helps you out in the process. Either way is fine.